Right, now we're going to take a look at the reverse star function. Alright, so look at the regular reverse function, which comes pre-built into Scheme. It does like A, B, C, then you get C, B, A. Alright, but what about this? Reverse A, B, C, D. Do you get D, C, B, A? No, you still have this one here. It doesn't go in reverse this list. It just does. It keeps that the same, and then does BA. So it only does the top level elements of the list, sort of like a flat list reverse. Alright, so now we're going to define a procedure called reverse star, which will actually go in reverse this, so that you get D, C, B, A. And then if there's lists within that, it'll reverse those as well. Okay, so the base, if you remember in reverse, we used append a lot. And we appended, like you appended the reverse of the coulter of the list onto the car, a list with the car in it. Alright, so that's going to be the basis of this, except that we're going to check the car and see if it's a list, and then run reverse on that as well. Alright, so define reverse lambda ls cond null ls. If ls is empty, then we'll just return the empty list. Alright, then let's see, if it's not a list, ls, then we'll just do that append thing. Not list, ls, append append the car of I almost made a mistake. Okay, so we check if ls was null, and otherwise it's going to be in a list. Well, it's always going to be a list pretty much. We can't handle it if it's not a list. Okay, so we don't mean ls here, we mean the car of ls. We're checking through the car now, and then we're going to reverse that and append it on the end. Okay, so if it's not a list, then we'll append the reverse. Oh, and another thing, we're calling this reverse star because it's deeply recursive. Alright, reverse star of the coulter of ls, and we'll put the car within a list so that append can append it. Alright, now otherwise, if it is a list, then we append the reverse coulter of ls like usual, but instead of putting the car of ls, we have to reverse that as well. So the reverse star of the car of ls. So that's it. Let's try and run this. Reverse star A, B, C. C, B, A, that's good. A, B, C, D, E. Oh no. Alright, so what's going on here? We've lost the list structure here. Let's try this again. What are we gonna do if we've got this? B, C, D, E, F. Now is that gonna be flat as well? You tell me. I say it will be. Oh yes it is. Alright, but at least oh, is it even in reverse anymore? So E, D, C, B, A, F, E, D, C, B, A. Well, at least we've got it in reverse. We just need to maintain these lists in here though. So we're appending this line is alright when we're appending the list of the car of ls. In this one we're appending the reverse of the coulter of ls, which is fine, But look at this one, the reverse, the cart of ls. So let's say this is a list here, then the reverse of that will be bcd. So let's say we've we're appending, like, I don't know, a, and then bcd. Now we want bcd to be its own list in this case, but see, append gets rid of that, so we have to put an extra set of parentheses around it to make sure that that it gets appended right. Alright, there, see, like that. Okay, so let's just put that into a list, then append will get it correct. Alright, let's try this again. Reverse star A, B, C, D, E, F, G, G, F, E, D, C, B, A. Alright, now that looks much better. Okay, let me see if I've got anything else. Just show you here. Nope, not for this one.